Right. Just a minor little reset there. Okay, happy Wednesday and welcome to the stream. My name is Nick Larson. Today is August 7th, 2019. It's about 12:04 in the afternoon and we're a little bit late because I just had a little false start because I forgot to set up everything about my stream information, but we're good to go now. We had a good week last week. We wrote a blog post about doing interviews and how to prepare for interviews. Got a lot of really good feedback on it from people as they were watching, which was really nice. Posted it and then realized that I made the huge mistake of not including the actual link to the video that we recorded the week before about the same content that like compresses all of that reading into like an hour of like watching me do all of this stuff. So that sucked, but it is what it is. And today, what I would like to do is move on, and I want to start working on this programming competition. So let's take a look at that. Give me just a second. I'm going to pull it up. All right. So this programming competition is azspcs.com. And it's Al Zimmerman's programming contest. And today we're going to do this thing called reversing nearness. Now, let's go ahead and take a look at this so that we can all understand how it works, allegedly. So you start off with an in by in grid, so it's always going to be a square, and it's actually a torus, meaning that it wraps around horizontally and it wraps around vertically. Okay? So each of these things starts out, you have AA, BA, CA, DA, AB, BB, CB, etc., etc. The goal here is to look at the distances between each of the elements and then add them together. Okay, so you have AA to BA, that has a distance of 1. Then you have AA to CA, that has a distance of 2. You have to move over 2, but you can wrap around backwards, so the distance from AA to DA is actually only 1 because you just wrap around this direction. Right? Same thing going up, going down. And what you do is you calculate the distance between every single pair of elements in this grid, and then you're going to have to do the task. All right, so that's your baseline, and that's how far things are away. Now what you're supposed to do is reorganize all of the elements in this grid so that you minimize an evaluation function. And this evaluation function is you take all of those baseline values and you multiply them times the distance of all of the new distances in your modified grid. So here's a quick example, right? In the first one, in the original grid, AA and BA were right next to each other. But in this one, AA right here and BA right here are up 1 over 2. So up 1, and then that's 1 squared plus 2 squared. That's 5. So it has a distance of 5 because it wants the distance squared. So that's what we're looking at. Then you take the original value, multiply it times the transformed value, and what you see is that basically what you want to do is make things that used to be far apart close together and things that used to be close together far apart. And that will minimize the overall sum of products. And then that's it. That's the whole goal. I have never started on any part of this yet, but that's pretty much it. So I think the first thing that I want to do is build out the actual function that can get the score for any of these. And then I want to build something that can calculate, that can generate, shifted grids. And then what we're going to do is see if we can come up with some heuristics for how to look around in the space and see if we can end up finding a better way of going about it. Look around in the space and see if we can find a way to maximize the scores. Or I guess in a sense minimize them. Anyway, that's it. That's the goal. That's what we're going to do today. So let's get our code going. I'm going to start a new project for this. Bloop. boop. File, open folder. We're going to go to culture of development, and we're going to put a new folder here called what is it called? It's called reversing nearness. So that's what we're going to call it. I want to rename this reversing nearness. Okay. And then we want to say the old .NET new console. All right. If we can get these evaluation functions done, I'm pretty sure we can apply a greedy approach and at least get our names on the board. And I think, like, as far as today goes, that's what my goal is. I want to get our names on the board. I want to solve all of the problems. Oh, that's the other thing I should explain. So the problems are you take the values of 6 and you go all the way up to 30, and that is 25 problems. And you have a maximum score of 25. So if we go look at the standings, you'll see that the maximum score is 25, and this person has a really close to perfect score. It should be noted that these scores are relative to the other scores of everyone else. Right? So this does not mean that this person is, extraordinarily close to the absolute best possible solutions. It just means that relative to everyone else, they have found best possible solutions for almost all the problems. And that's what we're getting to. Okay. So we made ourselves a little program. Now what we want to do is have something called a board, right? Class grid private. We're just going to make all of these sure, put whatever you need in there. Okay, items. Okay, so what we're going to do is we're basically going to consider, for the purposes of having a representation here, that AA is 0. I think we're gonna translate this. So it's AA, AB, AC, AD, which will have the exact same score as if we were doing it vertically. It'll just be easier to reason about when we go through it. So it's going to be AA, AB, AC, AD, BA, BB, BC, BD. That's the way that we're going to think about it. And then all we want to do is come up with a thing that generates the score and then validate that the original baselines that we create are the correct baselines. Okay. And then we want to say grid equals public grid int size. We know that it's square, so we only need one size. And then we say items equals enumerable dot range. Where is my enumerable? Sure, using system.link. Enumerable, sure, using, oh, there it is. Okay, range. This is going to be size times size dot toArray. You want to start an account, so we're just going to put a 0. And then we're going to do a count of size times size. Okay, and then what we're going to do is have something called public in, oh, it's going to have to be a long get int array get distances. Okay, and then conceptually here, basically what we want to get is these, right? We want 1, 4, 4, 2, 1, 4, 4, etc., 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 all the way down, so that we can have the original, then we can have the other one, then all we have to do is take a dot product of these, multiply them, add them all up, and that will give us the score. And then the lower bounds, I believe, are going to be taking this, just the original grid squared, or treating the original grid and the second grid as the same thing. That's what I think. We'll know in just a minute. So get distances. The first one always needs to be 0, 0. So what we need to do is first get a lookup for, okay, so we need a dictionary lookup. Var lookup equals new dictionary of int to int. The idea here, seriously? Yes, okay, there we go. Sometimes I wish it would just do that stuff on its own. What we want to do is then say for int I equals 0, I less than items.length, and I should call this cells. I plus plus. We want to say that the value at I can be found at this index. So we want to say lookup.add of cells of I and I. So the value at this cell can be looked up at this location. That's all we care about. So we have created this lookup. Now what we want to say is for int I equals 0, I less than cells.length, I plus plus. Okay. So the output of this needs to be an int array of every possible one of these things. How do we figure out the total number that there are? If we have 25, we have 1 plus n. Okay, so if we had a 1 by 1 grid, then there's just 1. If we had a 2 by 1 grid, then there's 3. If we had a 2 by 2 grid, then there's 3. If we had a 3 by 3 grid, then there's 3, 4, 5, 6. So you take the first one. Is there guaranteed to always be an even number here? No. We can end up with a 3. You add the first number to the last number, and then you divide by 2. Right? So if we had a length of 3, we would add 3 plus 1 is 4 times 1.5. Or maybe we just do this the really naive way and just pre-calculate it. Private int pair. There we go. Oh, actually, I think this was actually specified. There are n squared times n squared minus 1 divided by 2 pairs of distinct tokens. Okay, well, that's my answer right there. So if it's 3, we have 9 times 8. What the hell? In an n by n grid, there are n squared times n squared minus 1 pairs of distinct tokens. Okay, so my size is 3. Then there are 9 cells. And I have 9 cells times 8 cells is 72. Okay, I'm just going to trust this as gold. That's my answer. And because one of these will always be even, then the total number of pairs is always even. So you have, okay, I can believe this. And then we're just going to say pair count. Okay, int total cells equals, let's just call it n, equals size times size, n, and then let's say pair count equals n times n times n times n minus 1 divided by 2. And I can't type. Times. Is that correct? If we had 4 total cells because it's a 2 by 2, then you have 1, 2, 3, 4, 5, 6. Okay, so I'm already thinking this is not right. Oh, that is my n squared. So this is now 4. Okay. 4 times 3 is 12, divided by 2 is 6. Okay, yeah, that's right. Okay. Now what we're going to do is say int I, nope, int array result equals new int of pair count, and then return result. Okay, then this is less than pair count. So now what we need to do is find the first one. Okay. total cells equals cells.length. Then what we want to do is say int first, okay, cell 1 equals I divided by total cells. Oh, that's not quite how I want it to go, is it? No, let's just do it in a nested format, I think. Okay, in a nested format. For int I equals 0, I less than total cells I plus plus. For int j equals 0, j less than totals equals I plus 1. That was the whole point. Less than total cells, j plus plus. Then I want to say that result of I times total cells plus j equals get distance of I and j. Okay, now how do we get the distance? We look up the values, look up the locations. Okay, so I'm going to do it like this. Save myself some lookups. Okay, int I loc equals lookup of I. Int j loc equals lookup of j. Int I row equals okay. This dot size equals size. Size times size. Okay, I just need to record the size so that I can say I row equals I location divided by size, and int I call equals I location mod the size. And then we want the same thing but for j. J row, j call, j loc, j loc. Okay, so now we know the locations of them. And what we want to do is we want to take the difference of them. How are we going to do that? Okay. We are going to say if we have, okay, well, let's think about on the same row. If we're on the same row and we're at position 0 and 3 and the width is 5, then we can take I want to if I take either one of them and add 5 to it, and then I subtract the other one. So if I take that location 2 and I add 5, we end up at location 7. And then I subtract the one that I now know is greater, and I subtract the one that is less, and then I mod it by 5. Does that... So it needs to wrap around. Right? So maybe I just take the minimum of 2 values. Oh wait, no, I can already tell you. If it's greater than the half distance, then I take the minus of it. Alright, so I have the locations. So now what I want to do is say, give me the difference between these things. Give me the absolute difference. Why does this seem hard? Give me the absolute difference in the row. Yeah, let's try that. Int row diff equals j row minus I row. And let's do math.absolute value of these. And int call diff equals math.absolute value of j call minus j minus I call. Okay. If you have 0 and 1, and you take 1 minus 0, you get a 1. If you take 0 and 2, 2, and the length here is 0 to 4. If you take 2 minus 0, you get 2. If you take 3 minus 0, you get 3. But we know that 3 is greater than half the distance. Is that right? It's great. Okay, let's do it like this. Row diff equals math.min of row diff and now how about half distance? All right, let's get the half distance. And half dist equals size divided by 2. That's integer math, so if that's 5, it'll become 2. So if it's greater than, row diff equals row diff greater than half dist, then it's something or it's row diff. It's size minus row diff. Right, if it's 3, then you take 5 minus 3 and you're 2 away. And I think that's right. We shall know in just a moment. Call diff equals call diff call diff call diff. All right, result equals row diff times row diff plus call diff times call diff. Okay, we can come back and see if there is a faster way to calculate this later, but what I care about most right now is verifying correctness. So let's take a look at our example that we have, which is a 5 by 5. And we want to calculate the distance in the original grid. Okay, let's do that. Let's say var grid equals new grid of 5. And then we want to say var dist equals grid dot get distances. I want to say for each var dist and dist console.writeLine of dist. How many are there going to be? 25 times 24. Oh, that's going to be a lot. It's going to be 600? That seems like a lot. One thing that we ought to be able to do is having something like static void. We'll know the answer right away because we can just do the dot product. Dot. This is going to be a long dot of int array A, int array B, long result equals 0, return result for int I equals 0, I less than a dot length I plus plus result plus equals a of I times b of I. Okay. 4 int I equals 0. Oh no, 1 I. Let's just do 2 here. I less than or equal to 30, I plus plus. Grid of I. Var dot equals dot of dist console dot right line of distance I colon and then dot. I think we want to do like a 0, 0 here or something like that. Okay. No idea if this is going to work. Unhandled exception index out of range. Get distances line 71. Result. Okay, let's debug it. Line 71. So it thinks I times total cells plus J. Oh. Yeah, that makes sense. Why that doesn't work. Okay. Current index. Int current result index equals 0. Current result index plus plus. Okay. Those numbers look like they might be close. What do we get? Somehow we got 12 and 90. Okay, so we're off. Let's take a look at size 2. Subtract the appropriate lower bound given in this table. Okay. These get off by quite a bit. Can you have a lower bound of 0? The answer is yes. Let's see if we can figure out 10 and how they came up with the lower bound. Right? So what we have is this box where it's like 1, 2, 3, 4. 1 to 2 has a distance of 1. 1 to 3 has a distance of 1. 1 to 4 has a distance of 2. 2 to 3 has a distance of 2. 2 to 4 has a distance of 1. 3 to 4 has a distance of 1. I am seeing how would you come up with a lower bound of 10? If you submitted the exact same then you would have a score. Oh, I see. So this is the worst possible score that you can get. Subtract the appropriate lower bound given in this table. So this says no matter what, you can't do better than 10. Is that true? If you did 1, 2, 4, 3, then 1 to 2 would still be 1. 1 to 3 would be 2. Oh, I kind of get it. So basically, if you take this 2 and you match it up with this 1, and this 2 and match it up with this 1, right, that's the optimal you can do. No matter what, 2 of your 1s are still going to be attached to other 1s. So this would result in a 10. I get it. So that's the lower bound. And the lower bound is unachievable or is achievable? Subtract the lower bound. How do you calculate the lower bound? I don't actually care. All I care about is copying them and pasting them in there. Okay, let's do that. Okay. Oh man, do me one. H tab. Okay, so it's D tab, D tab, D plus tab, D plus tab, okay, Control H, comma, replace with nothing. Replace all. Control H, D plus tab, D plus tab. Replace with, oh, let's go like this. Let's go with okay. Now let's go with replace 2 comma 3 comma new line. Yeah, all right. Missed that last one. Comma space. Okay. Control H, comma, replace all. Whoa. Replace all. Okay. Control A, Control C. And then let's go back to the code. And let's make this a constant somewhere. Which is like lower bound int oh yeah, whatever. Long lower bounds equals new. Okay. I think I need to do like a L on these. And I think I probably just want to do it like okay. One more time with feeling. Control H. Space D plus. Need to put in a 0. 0. D plus, comma, D plus, comma, replace with /1, comma. Replace all. Control A, Control C. Okay, now I can just do this as a long. Oh, I did it again. Undo. Control H. L. Replace all. Oh shit, that didn't work. Replace all. Control A, Control C. Long array lower bounds equals new okay. Okay, that's where the lower bounds come from. And now I want to get my score. And now what we do is we say return dot of A, B minus lower bounds of size. And that needs to be static. Okay, that's how you get the score. How is the actual scoring done? Okay, example 2 is better. For each value of n from 6 to 30, submit an n by n rearrangement with as low an evaluation as you can find. For each value of n you submit more than one, but only your best rearrangement will enter the scoring system. For each of the 25 values of n, we find your best rearrangement, that is the rearrangement with the lowest evaluation. Your raw score for that n is the evaluation for the best rearrangement. For each of the 25 values of n, we compute a subscore from 0 to 1. We do this by dividing that n's raw score into the lowest score for that n across all entrants. Your contest score. Okay, so whatever the lowest score is. Okay. So 80 divided by the lowest score. 80 divided by 912. Okay, so we can come up with a solution right now that just submits everything as is. I bet you somebody has done that. And we will easily be able to find it because there will be a lot of them. Yeah? No? Really thought there was going to be a lot of them. That is it right there. Okay, this is people who have done that. So that is the score that you get. Let's go ahead and get our names on the list and just submit those. And then we'll come up with some sort of like greedy heuristic to sort of search through. and see if we can find it. Okay, so once we have this, we now need to write it out. Once we have this, we now need to write it out. Okay, how do we write it out? That's a great question. No, don't save that. Once we have it, how do we write it out? I think we're good with this. Okay. Row by row. Sure. Let's okay. Static void save best. So now the way that we're going to do this is we're going to save one file for each size, so int size, and then we're going to say long score and int array values grid. I think we're going to just make this public. No, I don't actually need to do that. Okay. Now what we're going to do is say we're going to generate a single string, and then we're just going to write out a file. Okay. Generate string representation, write to file. Okay. Var sb equals new string builder. Then we're going to say, what do you mean? Come on, give me my help. Yep. For int I equals 0, I less than size, I plus plus. For int j equals 0, j less than size, j plus plus. And I think I'm going to want it like this, but maybe not. I'm going to say sb.write. Weird, I'm not getting... Seriously? Is it lower? Dot append. Okay. sb.append. Okay. If I is greater than 0, sb.append of a comma and a new line, and let's start off by saying sb.append of value, no, score, sb.append new line. Okay. File string file name equals best size .txt file file, let's make this system.io, file dot write all text, path, file name, contents, sb.toString. I think there's one more thing here, which is probably, let's go see if the file name exists. I don't really want to overwrite a file that has a good score in it accidentally. So let's just put the score in it. My only concern is that this is going to end up taking like gigs on my drive if we end up going through a bunch of these, so I'm just going to have to clean them out every once in a while. No, I'm not going to do that. I'm just going to leave it as 1, and if I overwrite it, we're just going to find another best one. I think... the other option is just like make this a giant JSON. Load it up and then write the whole JSON every time you come up with a better one. I'm not really going to worry about this. We're just trying to get started. For grid I dot I want to change this to var score equals score of, let's just change that to size. So's size, 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 size. There's a better way to do this, isn't there? Like Control R. Ooh. I'm sure there's a better way. I just don't know how to do it. Size, size. Dist, dist. Score. And I don't think we want that at all. And then what we want to do is say save best of size, score, and dist. And instead of doing this from 30, we just want to do it to 6. And let's fire it off. Okay, that's a lot of files. Let's go submit them. Oh, that's right, you have to actually fill them up. Well, there's that part. Okay, for int j equals, now what we want is okay. value of a cell tells you the row and the column. Okay. We need the value All right, we need the value. If we need the value. So what we need is int cell value equals grid of I times size plus j. Now we need the cell row. Original row equals value divided by size, int original call equals value mod size. Now what I want to do is say, let's create another lookup. Static char array cell name. Actually, we can just do this, and this will make this a lot faster. Since this is happening so rarely, I don't actually care about this. Okay, equals new. Needs to be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, V, W, X, Y, Z, 1, 2, 3, 4, 5. 3, 2, 1. Z. I can't do this backwards. B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. No, let's just leave Z. Okay. We're getting there. Once we get this output, then the fun starts. I tell myself that. There we go. Cell name. sb.append cell name of original row sb.append cell name of original call. If j is greater than 0, then append that. Okay, let's try this one more time. Oh. What in the hell? Oh, those are the distances. I don't want the distances. I was passing the distances in. Distances. I actually need the cell values. We're going to say this is cells. 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 Clearly I do this enough that I should learn how to do it. Okay. Oh, you gotta still pass in the cells. Grid.cells. Alright, AA, AB, AC, AD, AE, AF. BA, BB, BC, BD, BE. Okay, E's, F's, D's, C's, B's, A's. A's, B's, C's, D's, E's, F's. Alright. Alright, and now we have a working thing. Okay. Now what we ought to be able to do is like pull this over here and then go to the actual submission form. Oop. Gonna have to put this over here for a second. Actually, just take this out, go full screen. Doing so. Sorry. No audio. Can y'all not hear me? I think it is just you. Whoa. Oh. CM Griffin just rated with a party of 28. Holy cow. Thank you so much. There was no audio during that last part. Sorry, I was in private mode because I was logging into this website. So basically, well, thanks everybody for joining in. I really appreciate the raid. That's awesome. Hope you had a good stream, man. What were you doing? Today I am working on a programming competition, a really simple one. A simple one. It's an NP complete problem, so it's not exactly simple per se, but we're just getting set up now and just getting on the board with some entries and just getting our name started, and then we're gonna do some grinding away on some greedy formulations for this problem and see how far we can get this week. Just working on a chat overlay as a service for streamers. That's awesome. What does it handle? Oh, let's keep grinding away. 484. I'm gonna have to come up with a better way to submit these because manually copying them and pasting them isn't particularly fun. $13. Alright, once we get done with this, should be some really easy ways to like get more points. But of course, when it comes to NP complete problems, BTTV, it replaces arbitrary text emotes with custom images. Oh, that's cool. For the streamer's OBS overlay. Misuse of, for example, but I'm lazy. That's alright. Oh. Yeah, I gotta come up with a way to automate this part. Because this part is boring. Although, if I can get the best solution for, like, say, the first 5 or 6 of these, then I just won't ever have to worry about those again. Like, if I can actually achieve the lower bound. We'll see. Or I suppose, in the meantime, just submitting them isn't that big of a deal. I'm sort of surprised how many points you get for this. I really thought we were going to be down at the bottom. Hey, thanks for the follow. Meito04 and CM Griffin. I had to turn off my notifications because the last time I got raided, we got raided by some trolls, and it was really bad spam all over the place. But thank you so much for the follow. I really, really appreciate it. And once we get done, then we're going to move on. Alright, so this is like the trivial way of getting points. Meaning that anybody who enters can get at least this many points without question. Which appears to be over 8. Alright, so you can get 8.29 points in this competition by simply submitting an entry, the most naive entry for every single one. Let's go down and check the videotape. Nobody else has done that. Interesting. Okay, let's go ahead and do something greedy now. For those of you who just followed, the way that this thing works is kind of fun. It's a grid It looks like this, and it wraps around horizontally and vertically, essentially making a torus. So you can get to anywhere else from anywhere else, going in any direction that you want to. The items in your grid must start out in this order: AA, BA, etc., etc. The grid size is always going to be square, and the goal is to initially calculate the distance between each element and every other element. So AA to BA has a distance of 1, AA to BA to CA has a distance of 2, and then AA to BA to BB has a distance of 2 because you have to go right and then down. Okay, the distance is this squared plus this squared, right? So if you have to go 2, it counts as 4, and if you have to go 3, it counts as 9. However, because this wraps around, you can go 2 in this direction, but you can get to DA by wrapping around to the left here, right? Once you have this baseline for all of your values and how far they are from one another, then your goal is to rearrange all of these things in such a way that the new values, when multiplied together, create the smallest possible distance. Okay, so to give you an example, if we had a 5 by 5, it would start off with AA, AB, AC, etc. And then we rearrange it to look like this. And then you can calculate the score by taking the original distance between these two things and then multiplying it times the new distance to these things. So essentially the goal is you want to take things that used to be far apart and you want to put them really close together, because a big number times a small number is generally a small number, but a big number times a big number is a really big number. So you want to avoid big numbers times big numbers as much as possible. And that's the overall goal of what we're trying to do here. Effectively, all we've done so far is set up a way to create the grid, to get the distances between all pairs of elements, and then to calculate the overall score based on the rules that are given to you, which is basically to calculate this total product and then you subtract out a lower bound that they give you in this table. Don't ask me how they calculated the lower bound. I have no idea. That's just how they tell you to do it. And so that's what I did. You subtract out the lower bound, you end up with a score, you submit your results. Now what we want to do is we have a way to calculate the score. And what we want to do is I think we want to take every possible pair of elements and we want to try swapping them and seeing if we gain or reduce, whether we improve the score or whether we decrease the score. And we always want to, from wherever we're at, take all of the scores for the next possible step and then just chase it down the path of choosing the next best possible score. That's a very greedy approach, but I have a feeling it's going to work okay. So we're just going to give it a shot. And we're just going to call this static void greedy best next. And this is going to be int size. And this is going to be static void baseline. Okay. I'm going to say baseline. Going to comment that out. Going to say greedy best next. We're going to start with a small one. 6. And see how it goes. So the first thing that we're going to do is create a grid. And then we're going to say, all right, so here's another thing that I think we can do. Because you can shift this thing in any direction that you want to, you can set an anchor point and you can say no matter what, this one value is always going to be in exactly the same place, because you could just shift it around no matter what to force it so that that value, because it's a torus, you can shift it so that that value is always in the same place. So what we're going to do is we're going to say that AA, the top left-hand corner, never moves. We will only ever consider moving other things. And this should somewhat reduce the complexity, because we're just never going to move. We're never going to move the first one, so we'll never get in the. I don't know if we're going to get in a process of chasing our own tail, but we'll see. Okay, so what we want to do is say get all possible successors. How are we going to do that? Okay, effectively this is going to be while true, get all successors, score all successors, pick next best if it's better than current. Okay. Now what we need is var baseline equals grid dot get distances, baseline dist. Okay, and then we want to say get all successors of a grid, which I think we'll just put in the grid. Right? That makes sense. Public grid array get successors. Okay. Throw new not implemented exception. And then we can say var successors equals grid dot get successors. Okay. And then we can say var scores equals successors dot select score of baseline. Oh wait. Score of baseline dist. Oh no, size. Baseline dist and grid dot get distances. No, successor m dot get distances. And then we want, so that's the score. Let's put this on the next line. Let's put this on the next line. Let's put and then not the score, but what's the other one? The actual successor. Grid colon m. Okay, so now we have selected them. Dot order by descending. of m dot score. That to array? Sure. Okay. Long best score equals scores 0 dot score. Okay. That's the best score. Oh wait, but not descending, we want order by ascending. Okay. Now what we're going to do is say var best score equals score of size baseline dist. Okay. Best successor score if best successor score is greater than or equal to best score, then break. Otherwise, we want to say best score equals best successor score, grid equals okay, now we want all of these. We want to get a random one that has the best score. Okay, how do we get a random one that has the best score? Ooh. How do we get a random one that has the best score? Let's just say scores dot take while m dot score equals best successor score dot to array var best equals, now we need a random, static random equals new random. That's good. Okay. Grid equal best of random dot next of a max value of best dot length dot grid. Okay. And then we also want to save best of size best score and grid dot cells. Okay. So this will just kind of run and get better and better and better and better and better. Ideally. Let's just see how it goes. We're on 6. So as this gets better, this score should go down. Let's see if it works. Method? Oh yeah, that's right. You have to actually implement the methods. Get successors. Okay. List. Okay, var successors equals new list of grid return successors dot to array. Okay, for int I equals 2. Nope, I equals 1. I less than cells dot length I plus plus. For int j equals I plus 1. J less than cells dot length j plus plus. Successors dot add grid okay, let's just have a copy function. Private grid copy return new grid yeah, size var copy. Okay, I equals 0. I less than copy dot cells dot length, then cells dot length. Okay, copy dot cells of I equals cells of I. Return copy. We're going to say our successor equals copy. Successor have a private void swap int a cell 1 int cell 2. Okay, long a equals cells of cell 1 cells of cell 1 equals cells of cell 2 and cells 2 equal a. Is that an int? Sure, whatever, int var. There we go. successor dot swap ij successor. Okay, I have no idea if this is going to work. So basically what we're saying is get me all the successors. Successors are defined as leaving AA alone, so starting at cell 1, and then swapping it with each cell that comes after it, so that we don't end up doing each of them twice. Yeah, I think that's it. I think that's it. To create a successor, we create a whole new grid, which does the enumerable.range to create new memory for cells. And then we copy over the values. I could probably do it more like buffer dot block copy. And do source cells, source offset 0, copy dot cells, and do the length 0, cells dot length. Okay. That way I don't actually have to write all of that, and I'm sure this will be a lot faster. Actually, I don't know for sure. Okay. That is the source, starting at 0, going to the destination, starting at 0, writing the total length. Okay. I have actually written a swap. I feel awful about that. It is what it is. You create the successor. You swap the values. Do I need to update anything else? We have pair count. We have size. No, I don't need to update either of those. And we add the successors to the list. Alright, there's an excessive amount of allocations going on here, but I'm just not going to worry about it for now. I just care about the correctness and whether or not it runs. If it's slow, we'll deal with that later. There is something I want to do. I want to put some output. Greedy. Let's do something like int successors explored equals 0. Then I want to do I think I want to say scored. And we're going to go with 1 because this first score right here. Actually, there's a better way to do this. Inside the score function, we do the calculation here. Okay. Static int scores calculated equals 0. Scores calculated plus plus. Then we say let's do a little log. Static void log string value. Okay, console.writeLine of $, date time.utc now. And value. And let's go with object value so I can just send anything to it. If scores calculated mod, I don't know, 10,000 equals 0, then log scores calculated. Let's see how that works. Creating this template will make changes to existing files. What the hell? Oh, I don't want to do that. I want to say .NET run. Goodness me. I'm kind of glad it did that. Oh. An item with the same key has already been added. Key value 3. Dictionary try insert. 177. That means I have made a mistake. So we want to debug. Take a look at cells. Oh. Okay. So 3 somehow 2 disappeared. Okay. Let's go to the get successors because this is happening right away. Let's launch it. Successor cells that worked, right? The 2 and the 1. Let's look at cells. Nope, that's still good. Successor. Successor. Oh, that screwed up. Okay. So this one works correctly. Then we get a successor. Then I is 1. J is 3. Cells of 1 is 1. Cells of 1 get set to cells of 2. Okay, so A is 1. Oh, here it is, cells of 2. There you go. All this time and I wrote a swap incorrectly. That's what 10 years of being a software developer has done for me. Okay, great. Let's try this one more time. Debug. Still screwed it up. Key 29 this time. An item with the same key has already been added. Oh. I don't want to stop. I want to get to the error. Cells. Okay, so 8 is missing. And it should have been in 28. I equals 28. Somehow. All right. Somehow I am getting to the point where swapping is still creating an invalid do if j equals 28 and stop me equals 1. Okay. I know it's never used. We're just gonna roll with it. Seriously? You're not gonna run because of that. Successor. Okay, 3, 4, 5, 6, 7, 8. This is where it had the problem. And in fact, that worked. That worked. Wait, it exited with code 0? What? Maybe I just forgot to save? No. This time it's 23. Okay. Well, I am not going to be able to finish this today, unfortunately. And we are not even getting to the point of finding a single improvement. program. Are we? How about we go log best score. This will let us know if we're even hitting that. Okay. It appears we are hitting that one time and then exiting. Let's go with initial score. Initial score. Let's try that one more time. Okay, it is finding a new best score, but it doesn't appear to be changing anything. A's, B's. Oh no, it did change something. Okay. Let's go ahead and submit it just because. Maybe I was incorrect about how good of an improvement it would have been. Okay. It's got us a little bit more. Okay, I have to run because it's 2 o'clock and I have to take my kids to the gym. But I will be back tomorrow at noon Eastern time, and I am going to continue grinding away on this. And then again on Friday at noon as well. Thank you so much for joining, and let's go ahead and find somebody to raid real fast. Live. Discover. Let's go with Talk to Me Gooseman. All right. Yeah, thanks so much. I can barely read your name there. Nimolo? Yeah, thanks so much for checking it out. Like I said, I'll be back tomorrow. Please come watch. We'll see if we can come up with a better way to go about this. Clearly, we did not have a huge improvement this time, but we'll figure it out. All right, here we go. We're going to go watch Talk to Me Gooseman, and we'll see everybody hopefully again tomorrow. See y'all. Bye.